Dear First Secondary, Assalamu alaikum wa rahmatullahi wa barakatuh. It's Mr. Ahmed Mahmoud with you today to introduce a new mathematics lesson. Today, inshallah, we have the first lesson, geometry lesson in this term. Inshallah, the geometry divided into two units. The first unit related to the similarity or called the similarity. In this unit, inshallah, we are going to complete what we studied in the second prep. Okay, and in the second unit, we are going to study parallel lines and angle bisectors. Okay, the lesson here is unit 3, lesson 1, is called Similarity of Polygons. In this lesson, we just revise what we studied in the second prep. Let's start this lesson. Similarity of polygons. First, we need to remember what the meaning of similarity. Before we studied the two congruent polygons. The two congruent polygons, two polygons that have the same shape and the same size. But if we have a polygon like this, and this polygon called ABCD, if I make enlargement for this polygon or minimizing for this polygon, the enlargement be like this. Okay, so the resulted polygon, which is called XYZL, for example, is similar to the original polygon ABCD. Again, the polygon XYZL is the enlargement of the polygon ABCD, so the two polygons here are said to be similar. Similar means have the same shape but different size. Again, similar means have the same shape but different size. Okay, let's study the properties of similarity of polygons. The two polygons are said to be similar if the following two conditions satisfied together. Okay, we have two conditions. One condition related to the angles and the other related to the sides. First, two polygons are similar if the corresponding angles are congruent. What the meaning of corresponding? Corresponding means have the same position. For example, the first angle with the first angle, the second angle with the second angle, the third angle with the third angle, and so on. This is the correspondence between the angles. So the first condition is that the corresponding angles are congruent or equal in measure. Okay, for example, if we have two polygons ABCD and XYZL, and it's clear that they are similar to each other. Okay, to be similar, so the corresponding angles are equal in measure. What is the corresponding angles? A corresponding to X, and they are equal in measure. B corresponding to Y, and they are equal in measure. C and Z, D and L. Each two corresponding angles are equal in measure. The second required, which is related to the sides, it's clear that AB is not equal to XY and BC is not equal to YZ, but there is a constant ratio between the sides. For example, if this side AB equal half XY, so BC must be half YZ, DC half ZL, AD half XL. This is for example. This, what I said, is called proportional. Okay, so the lengths of the corresponding sides are proportional. For example, if I give you the lengths of the sides like this, here 3, 4, 5, 4.2, 4.5, 6, 7.5, 6.3. Okay. If I make the ratio between each two sides like this, 3 divided 4.5, 3 over 4.5, it is equal 3 over 2. It's equal 2 over 3. And the ratio 4 to 6, 4 over 6, equal also 2 over 3. And the ratio 5 over 7.5 equal also 2 over 3. The ratio 4.2 over 6.3 also equal 2 over 3. All ratios are constant, equal to constant ratio 2 over 3. So this is a proportional between the sides. So proportional means there is a constant ratio between the corresponding sides. Okay, so if ABCD is similar to XYZL, so AB over XY equal BC over YZ equal CD over ZL equal AD over XL, and this is called proportional between the sides. This proportion equal a constant, we are going to call it K. K looks like 2 over 3. K is the scale factor or the similarity ratio, like this. Again, K is similarity ratio or scale factor. Okay, let's study the first example with us. Okay, in this example, ABCD is similar to EFGH. This is a given. So I'm going to use this given to find the missing parts. Okay, as I said before, since the two polygons are similar, so we have already two conditions satisfied. What? A and E are equal, B and F are equal, C and G are equal, D and H are equal. Okay, and AB over EF equal BC over FG equal CD over GH equal AD over EF. This is a constant ratio. Okay, the required number 1, find the scale factor. And the required number 2, okay, let's solve the first required and see the second required later. Okay, the scale factor, since A, B, C, D is similar to E, F, G, H, therefore scale factor equal any two exist sides. Okay, here we have DA equal 12 and HE equals 8. Okay, there is two corresponding sides, their lengths are exist, so again AD over EH is the scale factor, AD over EH, which is equal 12 over 8, which is equal 3 over 2. Okay, now I need to say that you can find the scale factor by divide ABCD over EFGH, or the ratio here will be 3 over 2. Okay, some of you can start with this polygon, divided this polygon EFGH divided ABCD like 8 over 12. The ratio in this case will be 2 over 3. Okay, in both cases you the answer is correct. So the scale factor is 3 over 2 or 3 to 2 or 2 over 3, but it's better to start according to the order he gives you. He starts with A, B, C, D, so it's better to start with 12 over 8 according to the order. Okay, the second required with us. Here the second required, he asked me find X and Y. Okay, it's very easy. Here I will make the proportion. A proportion comes from this one. AB, EF, BC, FG, CD, GH, AD, EH. Okay, now I'm going to substitute with the given ratios. AB over EF, Y plus 2 and 6. Okay, BC, FG are not exist, so I will not write this ratio. CD, 15, GH is X, and finally AD equals 12, HE equals 8. Okay, now I can find X and can find Y. I will find X by make a cross multiplication. X equal 15 times 8 over 12. Again, 15 times 8 over 12. So X equal 10 centimeters. Y plus 2 equals 6 times 12 over 8. Again, Y plus 2, 6 times 12 over 8. Again, 6 times 12 over 8. So it is equal to 9. I'm going to send plus 2 there as minus, so Y equal 9 minus 2 equals 7. So X equal 10 and Y equal 7. Here the second example with us. In the opposite figure, triangle ECB, CBA, CBA is similar to triangle CED, CED. Okay, I can say that angle C and angle C common. B and E are equal. Angle B equal to angle E. A and D are equal. So angle A equal to angle D. Okay. Now using the shown on the figure, find the length of ED and EA. Okay. It's better to call AE X or Y or any letter. Okay. So since CBA is similar to triangle CED, therefore and make the proportion between the sides. CB, CE, BA, ED, CA, CD. Okay, here 12. 12 comes from 5 plus 7 and over 4 equals 9 over ED and CA equal 4 and X, so I will call it X plus 4. Over 5. Okay, now I can find ED equal 9 times 4 over 12. 9 times 4, 36 over 12 equal 3. And X plus 4, X here means AE. X plus 4 equal 5 times 12 over 4 or 5 times 9 over 3. Both are correct. Okay, it is equal 15. Send 4 as minus. So X equal 15 minus 4 equals 11. Okay, next, let's study the cases of the scale factor K. Now, the cases of the scale factor K. The similarity has three cases. The first case, when we make enlargement for the two polygons. Okay, this is the first polygon. If I make enlargement or magnify to this polygon, the other polygon will be greater than the smaller. This one is called enlargement or magnification. In that case, k will be greater than 1. It said that the second polygon is magnification or enlargement for the first polygon, so k here will be greater than 1. The ratio will be greater than 1 and it's called enlargement. The second case, if the first polygon, if we made a reduce or reduction for the first polygon like this, so the second polygon will be smaller than the first, and in that case it said that the second is minimizing or shrinking or reduction for the first polygon, and in that case k will be smaller than 1. But in that case k is smaller than 1 but it is greater than 0. Excuse me, I will write it with another color. Again, k here greater than 0 because k is not negative. Okay, k is smaller than 1 and greater than 0. This is in this case. Here k greater than 1. The third case, if the two polygons are looks like each other in everything or congruent. Okay, here in this case the scale factor is equal to 1 and it's called that the two polygons are congruent to each other. So we have three cases: enlargement, shrinking or reduction or reducing, and congruent. Bigger than 1, k here, k smaller than 1, k equal to 1. Okay, now we have some remarks. The first one with us, if we have two polygons like this and they are congruent. Okay, so if they are congruent, then they must be similar to each other because the congruency is a special case of the similarity. So if they are congruent, so they must be similar. If the two polygons are congruent, then they are similar. But in the opposite case, if we have a polygon like this and another polygon is enlargement for the first or minimizing for the first, so in that case they are similar but they are not congruent. So if they are congruent, then they must be similar. But if they are similar, so it is not necessary to be congruent. Okay, it's not necessary that the similar polygon are congruent because the similarity is not special case from the congruency. Okay, final. If we have a polygon like this, and this polygon is similar to another one. Okay, let me call this one polygon 1 and this one polygon 2. Okay, so 1 is similar to polygon 2. And if we have a third polygon, okay, this polygon is minimizing for 1 and I will call it 3, and 3 is similar to 1. In that case 1 is similar to 2 and also 1 is similar to 3, so 2 and 3 also are similar to each other because they are similar to a main polygon. So we can say that if each one of two polygons is similar to a third polygon, then the two polygons are similar to each other. Okay, now remember with me the regular polygon. The regular polygon is a polygon in which all its sides are equal in length and all its angles are equal in measure. In that case, we can say that all regular polygons which have the same number of sides are similar. For example, if we have equilateral triangle like this and another equilateral triangle smaller or greater than this one, than the first one. So they must be similar. Another case, if we have two regular quadrilateral, the regular quadrilateral is called square. Any two squares are similar to each other. Any two regular pentagons, the pentagon which has 5 sides are similar to each other. So any two regular polygons have the same number of sides are similar to each other. Okay, now there is a relation between the perimeter and the scale factor. Okay, for example, remember with me the first example that I have explained before. This example we have studied in the beginning of the lesson. We had A, B, C, D and X, Y, Z, L, and they are similar, and the corresponding angles A and X equal, B and Y equal, and so on. And the correspondence between the sides has constant ratio 3 over 4.5 equal 4 over 6 equal 5 over 7, and so on, 5 over 7.5, and so on. Okay, all of them equal to the given ratio 2.3. Now let's find the perimeter of this one and the perimeter of this one and find the ratio between them. Okay, the perimeter here equals 3 plus 4 plus 5 plus 4.2, which is equal 16.2. And the perimeter in the second polygon equal 4.5 plus 6 plus 7.5 plus 6.3 equal 24.3. Now, if I divided the perimeter of ABCD over the perimeter of XYZL, we get 16.2 over 24.3. In the simplest form, it is equal to over 3. It means what? It means that the ratio between the perimeter equal to the ratio between the corresponding sides, or equal to the scale factor. Okay, so the ratio between the perimeter of two similar polygons equal to the ratio between the length of two corresponding sides of them. And it's very clear and very important. Okay, example 3. Here in this example, we have ABCD and DEF are two similar triangles. Okay, DE equal 8, EF equal 9, FD equals 10, as we see. And the perimeter of ABCD equal 81. Now we have the sides of the first polygon and the perimeter of the second polygon. Find the sides of triangle ABCD. Okay, it's better to make the unknown up and the given down. Again, the unknown up. So, since A, B, C is similar to triangle D, E, F, therefore, AB over DE, and DE here equal, okay, I will write it as letters, DE equal to BC over EF equal AC DF. Therefore, AB equal 9 over 9 equal BC over 9, this is 8, excuse me, and AC over 10. The ratio between the sides equals the ratio between the perimeters. Here I can write perimeter of A, B, C, and here perimeter of D, E, F. It's equal to 81, and the perimeter of this one, 9 plus 8 plus 9 plus 10 equal 27. So it's easy to find AB. AB equal 8 times 81 over 27 equal 24, and BC equal 9 times 81 over 27 equal 27 centimeters, and AC 10 times 81 over 27 equal 30 centimeters. Example 4. Two similar triangles, the perimeter of the first is 74 and the length of the other is 4.568. Find the length of the longest side of the first triangle. Okay, now I will call the first triangle S1, sides of the first triangle S1, S2, S3. Okay, since triangle 1 similar to triangle 2, therefore S1 equal over 4.5 equal S2 over 6 equal S3 over 8 equal perimeter of the first polygon, which is 74, over the perimeter of the second polygon, 4.5 plus 6 plus 8 equals 18.5. Okay, equals the square factor 4. So I need the longest side. The longest side over 8. So S3 equal 8 times 74 over 18.5. Here S3 equal 32 centimeters. Now we have example 4. In the opposite two figures, polygon ABCD is similar to polygon XYZL. Required number 1, calculate measure of angle XLZ and the length of AD. Okay. Now in this one, they are similar. So angle A equal to angle X equals 115. It's easy to find the angle L. It's very easy because the polygon, the sum of its angles equals 360. Okay, since A, B, C, D is similar to X, Y, Z, L, therefore measure of angle X equal to measure of angle L equals, angle A equal 115 degrees, since the sum of the quad relateral equals 360 degrees. Therefore, measure of angle L equals 360 minus open brackets 115 plus 85 plus 70 equals 90 degrees. This is the first required. The second required, find the length of AD. Find the length of AD. Okay. Therefore, here AD over XL equal, I'm going to choose BC and YZ. BC over YZ. Therefore, AD unknown, XL equals 4.8, and BC equal 6, YZ equals 8. Okay, therefore AD equal 6 times 4.8 over 8 equal 3.6 centimeters. Okay, now the second required, if the perimeter of the polygon ABCD equals 19.5, ABCD equals 19.5, find the perimeter of XYZL. Here, by looking to this ratio, okay, 6 over 8, this is the ratio which is called the scale factor. Okay, so therefore perimeter of ABCD over perimeter of XYZL equal 6 over 8. Therefore, ABCD equals 19.5 and perimeter of XYZL here unknown equals 6 over 8. Therefore, perimeter of XYZL equal 19.5 times 8 over 6 equals 26 centimeters. Okay, now the next example. Here, example 5. The dimensions of a rectangle is 10 and 6. Find the perimeter and the area of another rectangle if the scale factor is 3. Okay, as I said before, make the unknown up and the known down. Okay, since rectangle 1 similar to rectangle 2, therefore L of the unknown 1 over 10 equal width over the unknown 1 over 6 equal 3. 3 here is the scale factor. Therefore, L equal 10 times 3 equals 30 centimeters, and W equal 6 times 3 equals 18. Okay, therefore the perimeter of the rectangle of the unknown rectangle equal length plus width between brackets times 2, 30 plus 18 all times 2. This is 48 times 2 equal 96 centimeters, and the area of the rectangle equal length times width, 30 times 18 equals 540 centimeter square. Now let's study a very famous ratio called golden ratio, and from this ratio we created, or the mathematician created a rectangle called golden rectangle. Okay, what is the golden rectangle? The golden rectangle, it's a rectangle in which can be divided into square and rectangle similar to the original rectangle. What does it mean? Here, for example, if we have a rectangle like this, okay, I can divide this rectangle into square and another rectangle such that the new rectangle is similar to the original rectangle. Again, the main rectangle, like as we see, divided into square and rectangle. This rectangle similar to the original rectangle. Okay, they discovered that the ratio between the width of the rectangle and the length of the rectangle is constant, and this ratio is 1 to 1.618, and you're going to keep this 1 to 1.618. Okay, now according to the definition, if we subtract this square from the rectangle like this, so we have here a resulted rectangle. This rectangle also is a golden rectangle. The length between its width and its length is 1 to 1.618, like this 1, and this is 1.618. This is the ratio between width and length. Okay, this golden rectangle, if I subtract this square from it, so the result here is also a golden rectangle. The ratio between its width and its length is 1 to 1.618, like this. So if I subtract another square, the result is also a golden rectangle like this, 1, 2, and so on with no end. So the ratio between the golden rectangle between its width and its length, 1 to 1.618. You are going to study this number. Okay, we used this golden rectangle to form the display of the TV, or the display of the computer or laptop, or the mobiles, like this. If we use this rectangle, the rectangle of the TV here is golden rectangle. Okay, and by looking to the laptop or the computer, its screen also is a golden rectangle. The mobiles is a golden rectangle. The tablets also golden rectangle. Okay, and some artists use this one. For example, the Mona Lisa portrait also is a golden rectangle. By looking carefully to this portrait, is divided into square down here and rectangle. This rectangle is also a golden rectangle. By subtract this square, it gives me a golden rectangle. By subtract this square, give us a golden rectangle. By subtract this square, give us golden rectangle with no end. So the Mona Lisa square portrait is also a golden rectangle. So we can say that all the golden rectangles are similar to each other, because all golden rectangles have a main ratio which is 1 to 1.618. Let's solve the next question. A box in the shape of a rectangle, its length 34 and its width is 21. Is this rectangle close to a golden rectangle, and why? Okay, now I will make the ratio between the length and the width. The length equal 34 and the width equal 21. 34 over 21 equal 1.619 and so on. So this is closed to be golden rectangle because the main ratio is 1.6118 and this is a very close to it, so it is a golden rectangle. And the reason is because the ratio is 1.619. Looks like the golden rectangle. Okay. Another example. The length of a golden rectangle box is 16.2 centimeters. Calculate the width of the box to the nearest centimeter. Okay, as he said in the given, it's a golden rectangle. So length over width, okay, equal 1.618 over 1. Okay, therefore the length here is 16.2 over the width equal 1.618. Okay, this ratio is over 1, so the width equal 16.2 times 1 over 1.618 equals approximately 13.869 and so on. But he asked me to the nearest centimeter. Centimeter means whole number, so the whole number here is the unit here is 3. The next to 3 is strong. The strong add 1 to the unit, so it will be 14, and ignore the numbers after the point. Okay. Example 8. If each one of two polygons similar to a third, then they are similar. If the scale factor of two polygons equal 1, then the two polygons are congruent. If k is the scale factor of similarity of polygon M1 to M2 and k between 0 and 1, so M1 is minimizing or shrinking to M2. And this is the end of the lesson. I hope it was helpful for you. See you in the next video inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh. Mr. Ahmed Mahmoud was with you.